Test, da li se čujemo? Okay, hello everybody. Welcome to the last C++ meetup in 2023. I hope that you will enjoy it, and we have some special talks, lightning talks this time. Unfortunately or fortunately, I don't know in which order we will present them, so this will be like an ad hoc presentation this time. But nevertheless, I like that there are a lot of people here on site as well. Before we start with the presentations, I would like for all of you that you are here to take your phones and scan one QR code that I will share in a second. It's not something indulging, don't worry. No, it's not. So please scan the QR code, and I would really like to fill in that you fill in this Google form. This is a feedback for C++ Serbia user group. And I intentionally start with this thing because otherwise, afterwards, I cannot persuade you to, to scan the QR code before drinking some beer and whatnot to celebrate New Year's Eve. This is why we are starting first with this one. And please take up some time, not more than 10 minutes, I hope, and then we will continue with the presentations. Thank you very much. Very appreciated. Okay, so did you finish already? Not that much, okay. But these are serious questions. So at least serious for me. Yeah, for us who are organizing this. Okay, thank you very much. So this questionnaire was very important for us in order to know how to proceed next year with organizing meetups. So as you saw already, it's very important for us to know how did you find out for the user group itself, and how do you get new information about some upcoming meetups, because I'm informed that a lot of people are very divergent in a sense that somebody looks up on meetup.com and a couple of people on Slack and someone on LinkedIn. And I tried to unify all of these channels somehow, but I didn't have any success. So hopefully we will have next year some unified communication regarding future meetups. Also, one more thing, I think that Slack channel next year will be deprecated because Slack, of course, it's a paid platform, and we will probably move on CPP Lang, and we will use our own channel, user group channel that we already have on CPP Lang. I think it's a natural thing because all of the user groups are also from Europe are also there, and that's a natural thing to do. And we will think about it how to move all the users from a current Slack channel to the new one. And also, I think that it's very important for me to tell you that next year I plan to redesign C++ Serbia website. And because this is a C++ user group and probably not a lot of web developers, but if anybody knows something about web development a little bit more, then I would really like to get some help from you regarding building a website, preferably in some markup language, because I started it like that, and I don't want any fancy effects or whatnot, but some functionalities need to be added. So thank you everyone for joining. Enjoy the meetup, and I don't know who is the first speaker. Probably, yes, Jovana is the first speaker. She told me already and I forgot. And Jovana, so this is our first lightning talk.
And it's going to take only 2 minutes of your time. Ciao, Pavle. So I see some familiar faces here tonight. We need to draw a circle here for the speaker, I guess. Welcome one more time. We have opened up this space for public 10 days ago, I think. And as you can see from the previous times you've visited, it's a bit different, right? So we have an arts exhibition. We're going to switch it every 2 to 3 months. All of the artists who are exhibiting their artworks are actually Serbian artists. Most of them are from the Faculty of Fine Arts. So we're kind of trying to, let's say, make a collaboration between the tech and the arts world. On the other side, as I said, we've opened this space for public. We hope to see more meetups happening here, except this user group. We're going to invite a lot of others. You're also invited to come here and to work if you're, I don't know, having a place nearby, or you just want to drop by. We'll have still some working hours. This is something like we're doing in progress with everything. We're not sure when are the people going to be here to let you in, because we still need to have cards and everything. But this is still work in progress, and you'll get some information through your user group about this space as soon as we have them on paper and officially. And that's about that. Be advised to just check out all of the artworks. They all have their price tag, because this is a sales actually of art pieces, and it's going to be like that every time you come. That's it. Thanks a lot.
So who would like to start first? I mean, you know, if there is no, okay, if there is no candidate, I will pronounce one.
Yeah. I did. I think that I made my presentation public now. Hi guys. Last year I talked about the unary plus or addition operator, and today I will talk about the comma operator. I copied this code and these examples from some references, which you will see later. For now, we can go to the first slide. Okay, so for example, we already knew, I don't know, that when we have operator comma, which it has to be in the parentheses. If you have something like this, if you have 1, comma 2, comma 3, it will always print 3, because the last value will be, I don't know, returned or evaluated. And all the previous values, we know that they will be calculated and they will be dropped after this expression is executed. So we can do stuff something like this. We can, I don't know, if you have an integer I, we can set it up to 3, and then we can add it, we can execute this expression, and we know that it will be 8. And we know that we usually have undefined behavior, because every compiler will do something different. And if we do this expression, we know that it will be precisely defined, because here we abuse the behavior of the comma operator, where it goes from left to right. So here we will set up I to 3, and then we will add it 2, so it's 5, and then we use this 5 plus 3, so we will print out 8, which in my opinion, is pretty cool, but it's something like a hack. Next, we can use the comma operator to get rid of this duplicate logic. For example, if we have process window events of some window, and if we have some loop, we can do something like this. We can make this while loop look like a do while loop, but we won't type do while. For example, we have while window is open, we will have this process window events, and then we can write something like this: process windows events, comma, is windows open. Then we can render or something like that, which is cool too. Then we can just jump to the examples. I type this in Godbolt. I mean, I have, let's see. It's open. Okay. So we can have this, some simple, okay, maybe I will need some technical skill. I don't know. This is Apple, I don't really know how to use it. I want this screen to share on the presentation. Yeah, so you can Google this. Okay, so for example, we can have something like this. We can have a class which is, we will try to make a class which will print out everything. We want to make a Python print in C++, and then we can have something like this. We can have my string, which is initialized here. Then we'll have the comma operators all over here. Then we have high and CPP. And we can see that it's executed correctly. So we have like high CPP, but with the comma operators. Okay. The comma operator is interesting because usually we know that it's executed from left to right, and all values have to be evaluated. And when it's overloaded, the thing changes. Then it's like we have, I don't know, we can make in our minds like this thing now. It's not like the ordinary comma operator, but it's like we call, I don't know, like recursive functions over each other. Like we have my string and then another parenthesis for my string and high and so on, like my string on high, comma CPP. And then we can have something like this. We can have high CPP. So it pretty looks like Python. But we have to take attention that if we have any other value, any other type, we can see that the type in this program is string. And if we do like, you can notice that this is the single quote, then the comma operator, the default behavior we can see it on place. Because if you have the default behavior, if you remember from the first slide, if you have 1, 2, 3, it will evaluate to 3. And this is the default behavior of the comma operator. So until the single quotes, it will be discarded. And then we will just have, oh no, what happened? And then we will have this thing over here. Okay, now I want to go to the second example, which will just use, well, I don't know how to go to the second example.
Okay. No. Okay. Spoil this.
Yeah. The second example uses the templated version of this. So in this version, we'll have a real, I don't know, a real Python print. This is the first example. We want a second. In the presentation. Yeah. Yeah. Okay. Okay, so I just added this thing over here where we have int c is equal 3 plus equals 2 c plus 3, and we will have the third line is 8. And before that, we will have different times. You see this is like a Python print, and we have print some stuff, comma, some stuff, etc. And we can see that it works. And how it works? Well, it just uses the template. Okay. We just have some structure print, and it will use this comma operator and the constref to any type that it goes. And that will be it. In the presentation, you have references where I found out this stuff.
Okay, who's next? Ivica?
I have a presentation on the TV. There is no presentation. Okay, but you still want me to share my screen? You need to connect it. Should I connect it? You can project from this side. See this? So the presentation is really short, so it will give you like a short introduction on how to get started with assembly. And so for people also C, C++ engineers, they know C++ really well. So for the C++ developers, so most of them know C++ quite well, but assembly is like a mystery a bit now. The question is, how can I get ramp up to assembly really quickly? So I have here, this is Godbolt. So you see here some function. It's really simple. It has a double result, which is 0, and then it sums up all the elements of this array A of I to result, and then returns the result. Now, the question is, so this is the assembly that's produced with optimization, enable, and so on. Now the question is, what does this assembly do? Now you're like not experienced, so what do we do with this one? So it's really simple. You just go to ChatGPT. Yeah, and you take this, you take the assembly, and you copy it, and then you say something, explain assembly, and then you paste it. Think so? Yeah. And to be honest, it's really good, like really, really good. So it will just tell you like one written x86, the function begins with the value of register SI. If it is 0, the code jumps to LBB 01, and then you can look at the code. So this is the test RSI error, and if it's 0, just to LBB 01. So RSI is some kind of register, and you can actually ask additional questions.
So it will jump here and return, probably just checking if the n is 0, the parameter, the n is the second parameter, and so on. So, and actually it was quite, explains really nicely. So it will take you, it will let you know whatever. It actually can also tell you like a disassemble, like this code is probably doing something in this side. So yeah, I was surprised to how well it does. So this is why I'm presenting it. And it's a really good start. Like if you don't know assembly, but you don't want to read the whole manual and figure out everything, you can just, I don't know the way you study, but normally how I like to study another programming languages is just what's the difference between the one that I know and the new one. And this actually works quite well. So that's it. Thank you. So I saw it, so I didn't go through it like
Can you ask it to give you an equivalent code in C++ to see if we'll get the original one?
So it will tell you, like, for when I pasted some examples of assembly, to say this code looks like a disassembly of this function in C++, but it works for really simple ones. It doesn't work for complex one. But the biggest thing when you work with assembly is you need to look up every function if you don't know it. And there are some idioms in assembly, like this XOR x66, which actually sets it to 0, but doesn't look if you don't know what it means. So it takes some time. This will like skyrocket your progress in assembly. Thank you.
Some Goran na slide. Like this slide. Imaš svoj komp ili?
Okay, so the next one.
Može Goran. Gorana, forwardovat ću ti mail. Možeš samo skinuti zip i samo na index.html zakraješ.
How's everybody doing?
Neću. Tako da speaker bio. Sad možeš ovo da privučeš, ovo drugo mi ostavi. Možda je F11. Može. Izvini. Okay. Thank you. So my topic is called template parameter reordering. So I got a little bit too excited last night, and I sort of dragged the topic on a little more than it should for a lightning talk, but I will try to condense it as much as I can so I don't take too much time from other people. Let me just jump right into it. So I'll just give a obligatory short lightning description of myself. My name is Arjan. I use C++ professionally for the last five years, and sometimes I even enjoy it. So let me give a brief introduction of what I mean by template parameter reordering. So let's start with an example that you probably already know, you're already aware of. So here I'm creating two tuples of the same types, so an int and a float and a string, except they're in different orders. So but all the values are the same. So my tuple 1 and my tuple 2 have the same values. And then what I'm doing is I'm trying to equate them, printing out the equal, if they're equal. And the second line right here is evaluating if they are of the same type. So does any audience member maybe know what the output of this program will be? Yeah, it does not compile. Well, it's very logical why it does not compile. The equal, it does not compile because these types are not the same. And why would they? A tuple by definition is an ordered type. So it makes sense. And if we were to comment that out, this same value would actually compile. It would say that it's false. Well, actually, it would say that it's 0 because it's C++. But it would be false because that's not the same type. Tuples are ordered. But a good question we can ask maybe is, can we have some variation of an unordered tuple? So something like a type set. Maybe I will answer this question in this presentation. Okay, let's generalize this thing. So what I've done here, I've just created this variadic template class called example, and basically just done the same thing. I've instantiated example with three different types. The three same types, but in different orders, and I'm doing the same thing. So you would think this results in the same behavior, but what if I told you there was a way to make this work, to not only make this compile, but actually equal evaluates to true, and the same variable also evaluates to true? Would you think I was lying? Well, let's see. Okay, so let's see if this is possible. Maybe first see why you would maybe want to do this. I usually don't like going into some abstract examples too much. From personal experience, it's not very helpful for me, but for the sake of argument, I will try to demonstrate it in some way. So for example, maybe you're writing some kind of framework for some type of processing node, and you want to provide the users of your library with the ability to declare the parameters of the template in various orders and have that actually evaluate to the exactly same code. So the processing node would actually be of the same type and it would behave the same way. And also the user would not have to think about in what order they should declare their parameters. So this could be an interesting thing that you could do, because it can provide a declarative syntax for defining some object. So in this case, you would have some type of variable amount of publisher subscribers for your processing node. And also, because we like to keep up with the times, and we like to be one of the cool kids. We don't like object-oriented programming. So we could maybe replace this first block of code that uses some classic form of dependency injection and creates and provides concrete classes for the complex system to work. Maybe we could, substitute that with zero cost abstraction complex system template class that can save us as much as one instruction per function call. This is a little bit of a joke, so please don't take offense too much. I like to sometimes joke on behalf of C++. Okay, so let's look at how this is possible. So what do I mean when I say template reordering? So let's look at this following line. Let's say we have some kind of template class called unpackAnimals, and we give it a couple of types. So we give it an animal, a double, cat, tree, a dog, and an int. And this right here type, that's just a type alias. And we call it filtered tuple. And what this thing will do is the filtered tuple will actually be a tuple of animal, a cat, and a dog. So what our nice little template class does, it filters out all the non-animal types and leaves just the animal types. So let's look at how this can be achieved. So this is the technical part, and I'll try to keep it as short as possible, not to bore you too much. But if you haven't looked into template metaprogramming too much, as I have not when I discovered this, I thought this algorithm was very, very nice, and it demonstrates how powerful template metaprogramming can be. So just briefly, here we have our variadic template class called unpackAnimals, and it's just defining this template, this type alias that is an empty tuple. And here we have a specialization of the same class. It's a specialization because this one takes one or more arguments and this one takes 0 or more. And don't worry about this part right here. We're going to ignore that. But let's look at the bottom right here. So this specialization defines this type alias with the std conditional. If you don't know what std conditional is, it basically says if this Boolean value is true, so if the first parameter, which is a Boolean value, is true, then this type alias will be equal to this, the second template parameter. If this Boolean value is false, this will evaluate to the second template parameter. So it's just a switch between those two. So let's look at what we actually called. We called this line here. So we called unpackAnimals with all of these template parameters, and we want to get this type. So what will this do? Let's do what the compiler will do, and let's substitute. So if we substitute all of this into here, what we will get is our conditional. So our conditional says, is animal a base type of animal? Which will say, yes, it is. And what will happen is we will take this first template parameter and not the second. So this one is ignored, and what this will evaluate to would be this. So what we got, so we will just get this cons and this and the rest. Oops. So now we have cons of animal, and then this is actually a recursive instantiation of the same template. So it's basically with all the same arguments except without the first one, which is double, which was the animal. So let's substitute it again. What we get is another conditional. Conditional now saying is animal the base type of double, which is false. So we don't take the first one, we take the second one. And as we can notice, the second one is basically the whole parameter pack just without the double. So we kicked out the double and we forgot about it. not to go into the whole iteration, but basically this happens a bunch more times until we get to the end, when all we have left is cons of animal, cons of cat, cons of dog, and an unpack animals empty with no parameter pack, which will take this, it doesn't fit this specialization, so it will evaluate this, which is an empty tuple. I'm missing some closing brackets, I think. So yeah, sorry, it was late last night. So basically what you will get after this is this line. And if you look at this cons template class, what happens here is we get, let's say we call cons, and cons means concatenations. We call dog and an empty tuple, which evaluates here to just std tuple of this head and tail is nothing, so we just get std tuple of dog. So the cons template class basically just concatenates all these, boom, 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 and what we get in the end is we just get an std tuple of animal, a cat, and a dog, which is what I said, so I didn't lie. So yeah, the filtered tuple is basically just you get a tuple and you get filtered out all the things that didn't match the predicate, which for us was the this right here, which is it a base type of animal? So you could generalize this a little bit. Let's say you wouldn't have to create a bunch of unpack template classes for every structure you have, but you could provide the base class with template parameter, and then you could call it just unpack by base. Or what you could do is you could do the same with some other predicate. So this time it's not is base of, this time it checks if they are actually identical, the types. And I'm pretty sure you could also generalize it even further with some kind of a filter template class where you could also inject the predicate. So you could inject this condition into directly into that template. But again, it was late last night, so okay. So let's talk about position independent. Let's return to the example code from before. This is the example code I showed earlier, exactly the same. It's time to come clean and say that I lied earlier. So there's no way for this to compile. But there is something interesting that we can extrapolate from the story before. So if we just make some small modifications to the earlier code, let's say we rename our example class to example implementation. Don't worry about it. And next, we define a type alias that is also a variadic type alias, and it calls it evaluates to our example implementation, but before instantiating that template, it makes all sorts of reorderings to that to the parameter pack. So these are all the things we saw before. So what this will do, it will take the parameter pack when we call example, and with whatever order that we stated, let's say animal, dog, cat, and we will basically it will filter out just the animal for the first parameter, just the cat, and just the dog for the second and third parameters. So what we will get in the end is these type aliases will basically transform into the same class. So this actually does compile, and equal evaluates to true, and same also evaluates to true. So this is kind of it's a trick. It's maybe a nice trick that you can do. Well, you could ask yourself, why would I do this? One of the reasons could be that maybe you want to provide your the users of your library or the users of your class a position-independent way to declare their instantiations, or maybe because it's fun. Or maybe you could maybe if you already tried to figure out some way to have position-independent arguments with by using some template specializations, maybe this could possibly simplify that process and simplify that code. So yeah, that's the end. Any questions? Yes?
Do you need a quantum computer to compile this?
No, I've implemented this in some parts of the code. It does take some more time to compile, but it's not that much. It's not that much, I swear, it's not.
I have one question.
Yes?
Do you support the same types or in a tuple, or all of them have to be different? Do you have some constraints for the
I think it depends on how you implement it. So maybe, so I think, yes, you can have the same types right here, but also with this filtering, it does not have to be a tuple. It can also be just a type. For example, if you expect just one type, or if maybe you want to, if you want to save yourself from the trouble of or save the user trouble of making a mistake in maybe, or let's say, if they enter the multiple types that match that condition, you maybe want to just take the last one or the first one. So you can basically return just one type. It doesn't have to be a tuple. Yeah, so sorry, I don't know if that answered your question.
Yes, and do you support assignment? And what about implicit conversions between some of the types? I mean, these are, I'm joking a little bit, but when you implement such things in real life, you would like to support these kind of things. For example, assignment of one of the object of that type to the other, and what would that be? Will you rearrange first the type and then assign every value? What if there are some different types, but they support implicit conversions?
Well, I'm not sure about that, but I think if you always use the type alias to create when you want to reference that, I think you should not have any trouble because it does evaluate the same type. But yeah, I'm not sure about. I mean, for this example, I actually had to explicitly write the comparison operator for it to work. But yeah. Oh.
Yeah, so I have a question. So if I read the code correctly, so the type that you created only works with these three types. For example, if you were to put a double and int and a float and then put int float double, it wouldn't work.
In this case, if you were to put int float double, yes, that would all get filtered out.
So okay, so the only possible set of example inputs that you could get are concretely
yes, that's true.
Example input of animal, dog, cat, or whatever.
Yes, that's correct? True. Yeah. Because right here, what I did is where did it go? What I did right here is the filtering I use is to check if they're the same. What you could also do is the predicate could be, is it a base class? So that would already open up your possibilities for template parameters for everything that inherits from that.
Yeah, actually, like beautiful thing is that it seems to me that you could write an equivalent code to this, which would be like 3 lines long for using concepts. Because what you could do is because the way you did it, you restricted the actual example to only being able to be animal, cat, and dog at the end.
Yes.
And because of that, knowing the set of types that are allowed, what you could actually do is just write requires that SD is same t/animal or t/cat or t/dog, and just dot dot dot. And by doing that, you could pretty much filter out everything, because the only 3 possible solutions for these are example impl of animal, example impl of animal/cat, example impl of animal/cat/dog. So like the fact that you've restricted the types that can be in it drastically simplifies the whole process of what you're trying to do. Like actually doing this with the capability of supporting arbitrary types. Like imagine a type set where you provide types and you provide them in any order and they're not known in advance, and being able to actually compare those kind of things. You couldn't use this kind of approach to do that.
Possibly. I didn't catch that last part.
Yeah, so basically, you've constrained the set of possible types that can end up in the example input to animal, cat, and dog. And if this set wasn't constrained, so if it could be any type, but you want each type to evaluate to the same underlying type. So let's say that you have a type set of ABC and you have a type set of BAC, and you want them to be the same without knowing what the concrete types are going to be passed. This kind of method wouldn't work, because in order to filter you need concrete types in advance to know what you're filtering.
Yeah, that's true. In this case, I mean, I would argue, well, I mean, if you can use something like this, it doesn't have to be the same type. You don't actually have to mention it. As I said, you could use like a derivative of the base class.
It's a meta function, essentially.
Yes, it's some relation. It has to have some relation. But I think it is often the case where you actually know what the types of the template parameters. So I wouldn't use this to create some collection of items. So like in the beginning, I said, is there a way to create an unordered tuple? Probably would not do that. I don't know why. I would, but for example, when I talked about why someone would do this, let's see. No, that's not it. Oh, right. Nope, that's not it either. Okay, this was it. So, for example, maybe you have some type of complex system, and you know what types you can expect to sort of build up this complex object. And what you can do is you can have some relation between these types, which could inherit from the abstract serializer. So it would know to expect some derivative of serializer, but also you could declaratively state it like this instead of saying, okay, user, the first template parameter is this, the second template parameter is this, and also I'll constrain you with concept. So if you don't do that, you will be notified. But in this way, you can it's like maybe nicer to code.
Okay, thank you. This was an interesting talk. Thank you very much. And who would be the next one?
Flash, isto princip kao njegova prezentacija potpuno. Ovo su, mislim, podeljene slike na dva monitora. Podeljen je kao dva, u principu imamo data. Tako. Samo da vidim da li mogu da otvorim taj speaker, neki view koji bi stavio na ovom računaru, čisto za neke novcove. I browser treba da dozvoli pop-upove. A ne. Znate, to super. Hvala. Znači, mogu da počnem. Da se mikrofon čuva? Aha, važi. So hello, I'll try to be short and sweet with this. This is like a question that I had from a few years, but I never really had enough willpower to try to research it more deeper, but I thought about that this presentation could be like a good opportunity to try at least to get a few objective reasons aside from like pure hatred that Linus Torvalds feels towards C++. So let's dive a little bit into this. Yeah. So I'll try to explain like some arguments that are against C++ in the kernel development for the start. The most important of all is AB instability, that in the time that the Linux kernel was developed in the 90s, it was a huge problem for C++, and it wasn't like, there wasn't a conventional AB for GCC compiler stabilized until like 98 or so, where the Itanium AB was chosen. So this is like the biggest, most objective reason for this. Let me see. Too used to this mouse to say. Second is the complexity, obviously. Well, I guess we can agree that it's fairly complex language, but to answer this question, I'll need like 15 years more of learning C++ to like know if it's truly complex to the end. And let's see. Well, we had, of course, the code bloat for the libraries that happens when you introduce the standard library of C++ and everything. It's also a fair argument that exists. And inadequate control over the abstraction mechanism that it provides. For example, I have for this is like, you cannot control the locations where you put the vtables for the inheritance and stuff that you can do it if you are only doing in C, and you can implement your own vtables and get rid of the abstractions that you don't have any control of. And I think the next one is, no, of course, this is also important. Linux kernel today has like 15 million lines of codes or something. So to actually convert this, it would be a huge development effort. And yeah, the next one is the most important, of course. Linus Torvalds is the most important reason why we don't convert. Yeah, I guess you probably all had a chance to get a little bit introduced to all the hatred that he has for the C++. It's, of course, a horrible language. As you can see, quite a few very nice words in this excerpt about his love for the C++. And let's see, of course, I managed to dig up by reading interviews about him that the guy is actually, no matter that he is like an extreme software genius, maybe the biggest software genius of all, he is, well, yeah, crazy, but extremely inert. Because, for example, he's using, I was reading about the stuff that he's using for his everyday development, and it says, he said that he is using some micro Emacs from the 90s or something like that, which is like a tool that ran out of support for like 25 or 30 years, but he's too lazy, you know, to get updated to something more. So I guess C++ argument could also be turned into that type of laziness. And here I put some, I was of course digging through the interviews that he had over the years, and he had some a little bit more objective reasons than just, you know, that C++ is a horrible language. So yeah, he says that in essence you can start with some abstraction that you need to define at the beginning of the project, and after 2 years you thought that you had some performance gain because of this abstraction, and like 2 or 3 years passes and you find out that this abstraction is like he says, utter crap or something like that. It doesn't work. And it's actually, he says that it's extremely difficult to kick it out after, you know, when you find out that it was a wrong decision to go with it. Where's my mouse? Sorry. So he also says, because he's working a lot with those mailing lists, you know, and he's reading the comments of the many developers, so when he gets patches for the Linux kernel, they get distilled through actually many people who are giving their opinions, discussing it, and when it reaches a certain point, only then he has gets to read the code, and he mostly reads the comment and stuff about it. And what he likes about the C is that you can immediately see the complete context of when you're looking at the code. And with C++, C++ has this tendency to like do a lot of things behind your back, which you may be aware of if you know the language well enough, but in most of the cases you are not aware of them, so it's like difficult to read the code in this type of way. Yeah, I don't know what, he says that C++ tried to resolve all the wrong problems, which is like not completely clear to me what he meant by that, but let's move on. Arguments, we are going to get some arguments for the C++. Well, almost zero cost abstractions, like const_expr is one really good example of that. Return value optimization is also a good example of that. It's a superset of C. For me, this is like really, really strong argument. I never understood why the fact that it's like completely supersetting it is not enough for many people to like accept the fact that it would maybe be a really good choice, but I don't know, like there are also a lot of problems, like you saw. Endless possibilities of metaprogramming. Yeah, this one I really like when you get, what? Yeah. Endless possibilities of metaprogramming, this is like one of my favorite. It's quite a magic, as you saw in the presentation before me. It like demonstrated this really nice, so you can, possibilities are literally endless. And what do we have more? Yeah, this was a really interesting argument for me, which I was curious to hear the other opinions because I couldn't find discussions on the forum. GCC translated to be completely written in C++ at some point. So, and Linux kernel is completely compiled with C++. So in my mind, when I contemplated this fact, it looked like that the fact that you can write a compiler in C++, and a good compiler like GCC in general is, literally means that you can achieve everything you need with the kernel also with this language. So for me, this is like a really, really strong argument that C++ could be very good for kernel development. And yeah, of course, easier development of advanced feature because you have, of course, many more abstractions under your fingers and capability to like use the fact that it's a superset of C. So if you contain yourself for some functionality to be strictly in a limited part of C++ and for the other that you need to use more advanced features like metaprogramming and stuff. So let's move on. Yeah, C++ was given a chance in its early development. It was like in 1992. And here we have it's an excerpt from a forum that I found that pretty much from a developer that developed like SCCI system in the Linux kernel. And he pretty much summarized that many of the arguments for not using it at that time are not viable today. In essence, like you can skip using the exceptions if you need them, like dynamic memory allocations still are a problem, but compiler issues that were like at 1992 were a very big thing. Now today's are, of course, not a problem anymore. So they tried it, like I said, in 1992. It was a very, very young language, and of course it was probably deemed for failure. And like I said in the first slide, 90s were a very tumultuous time for C++. GCC didn't standardize an ABI till the end of the beginning of the new millennia almost, and it was a pretty big problem. So the next big thing is that actually Rust became a kernel language instead of C++, which I found quite intriguing. Like, I know Rust is really safe and stuff, you know, but like, damn it, you know? And yeah, they managed to find their way inside, you know, Linux kernel, so it's a big success for the language. The good fact is that it didn't enter into the core, but it's only for the drivers and for the peripheral stuff of the Linux kernel, so they can find some consolation in that. And yeah, I don't know, like this seems that the future of the like answer of this question, will it sometimes be positive that like people actually, that Linux kernel actually could be sometimes, you know, changed to work with C++. It probably won't happen, but let's keep a tiny glimmer of hope for one day. So thank you for listening.
Thank you very much, Luca. Okay. Who would like to present next? I have some candidates in mind. Okay, then we shall. It's already prepared.
Trebalo bi da.
Jesi.
Okay.
Ajde vidimo šta je sa ekranom. To je jedna stvar, druga stvar. To da šerujemo, to je ekran na Zoom. Može se joinati sa Zoom.
Na sajtu, tako?
Jeste. CP servis kroz Meet. CP servis. Aha. Serbia.com kroz Meet.
Recording in progress.
Samo share screen. Samo trenutak.
Okay. Mhm. Okay. It was a bit of a process to set up the presentation. Give me just one more moment to mute my device. Okay. Yeah, this is okay. I hope we are ready for the presentation now. Unfortunately, my window manager is not getting along, so it was quite a bit of a process to set up just to be able to present it. I have prepared a topic which is kind of an interesting because I didn't know that in building that we are currently it was an exhibition recently, but this title has nothing to do with that. It was just taken, and somehow, even though it was not planned to be, to have the resemblance with that, but there it is. Okay, so today's presentation, it has titled Metadata Exhibition, and I believe you're all familiar with how we define custom types in C++. One of the main ways we can define custom types is by defining using a struct keyword followed by the type name and then having the fields in the body of the struct. But this is taken by the compiler, and compiler looks into this definition, and based on it, it provides some functionality that we can leverage from the compiler. For example, we can define a custom type, custom values by referring to the previously defined type, and we can state the values of fields that we want to be that we want to be a part of the struct. And therefore, compiler provides us with basically we can refer to its fields and we can get values. If you think about it, it is kind of a functionality that is provided by compiler, and that's something we are used to. And but if you really think about it, it's just part of the abstract syntax tree of the compiler. And compiler internally probably somehow needs to represent that information. And I have given here an example where compiler would, for example, you can imagine this as a dictionary or as a map that has basically for the key has the struct name, and then inside of the dictionary we can store that data type, imaginary data type called field, and basically it would be a vector of fields, and
Each field would have a name, and it would have a type. And for example, I just have given here an example, but it doesn't have to be like that. For example, if that field is a public or it's not. This is kind of a joke that I wanted to make. So what happens in compiler stays in compiler. Well, exposing compiler internals can be very useful at times, and I'll try to demonstrate how that is the case. There's this example from proposed reflection library that's still not in the standard as far as I'm familiar. It could be one day, maybe C++ 26, maybe C++, maybe 30 something, who knows. But this is an example of this is an example that demonstrates leveraging not just the data that's defined in the struct, but also leveraging the members. And in a sense, for compiler, that's also data. It's not metadata, but in our eyes, that's a metadata. And we can leverage that metadata to make some kind of a helper functions or anything else. In this instance, we are making a custom function that basically prints string value which is derived from the enum type. And you can imagine there's somewhere in the code is defined, actually it's here, this enum. And as you know, it's not possible in C++ just to get a string value. There are some tricky ways, and there are some libraries that can do that, but it's not first class, it doesn't have first class support. This is just a demonstration. If we would have this kind of a functionality in C++, we can make a lot of things that we can't make today. Okay, let's talk about struct metadata. Why? Why do we want this? There are plenty of examples where this can be useful. We can reduce a lot of boilerplate code. We can create another set of libraries that we can't make today, at least not with this first class support. We could make, for example, serialization libraries. We can make domain-specific abstractions, like we can make ORMs that can basically create SQL queries. We could also make it easier to define if we have, for example, some server applications where we're exposing web APIs. We would be able to make documentation automatically and a lot of other things as well. And because the C++ would probably have static reflection, that means that we can also have a good amount of, the performance would be pretty good. Okay, so these are some of the approaches when it comes to struct metadata. Obviously, the one that I already mentioned is reflection. There are also some other approaches. For example, in Rust, but also in other languages, we can use functionality called macros, which are not what we're used to in C++, because in C++ we use macros as as part of the preprocessor, and it actually just replaces a string. It's just string replacement, find replace, and it's not that great. But this kind of macros are, we're gonna see it in the example next, that these kind of macros can be very useful because they have a lot of more context and are type safe. Also, there are custom reflection systems. We're gonna see one example of that. I'm not gonna repeat this definition, but there was a talk by Dusan Jovanovic that you can look at C++ Serbia, and you can find more information about reflection in general. But yeah, you'll see some examples here as well. I created the example of reflection in Zig. Why in Zig? Because it was very nice. In my opinion, basically, we are iterating. So first we are defining the user struct. Oops. I hope. My battery is empty. We're going to try to handle this as quick as possible. Okay. Yes. Okay. I hope we're safe now. I'm sorry for the interruption. I had 50% when we started, but it's just draining. I'm canceling the shutdown. Okay. So let's see. Let's see this example. We're defining user struct with basically in Zig you would use basic an array of U8s to represent a string. Here we are defining a user constant. It can be a variable as well. And there's inline 4 in Zig, which basically unrolls the loop. And then we are leveraging this std meta fields function that you pass a type. This is somewhat new to C++ programmers. This would be equivalent of passing an argument to a template. And basically this construct would give us, I don't know if it's an array or what it exactly is. It's a range of fields. And we're iterating through the struct fields. And for each field, we're printing the field name. And we're printing the type name for the field. And also, we need to use this built-in function called field. And every built-in function in Zig is annotated with this @ symbol. And this basically, based on our value and based on a field name, it gets field with, from the whole struct, it gets value of the field that has this f.name. Also, we want to print that value. So to be able to print it in a way that is printed on the screen here, we need to, the string, basically the string type and the int types are printed differently. So in case of int, we're just printing the value. And in case of string, we're adding this s, which is kind of suggestion to the compiler to use to print it as a string, to print it as a string, and that's it. If we don't support any other types, but we could, and I guess we could make it even more generic. But this is just an example, so take it with grain of salt. Okay, and this is the output. Output, we have two fields. First field has name ID of type i32, which is int, and it has value 1. The second field has name name, and it has type const8 with value of this string, which is John. So if you think about it, first the compiler takes the syntax tree and it analyzes part of it, or it stores it in the compiler internals. That's indicated by this basically square here. And then in the other part of the AST, it basically uses what it previously defined, and it's able to get that metadata from compiler. And in our case, it's not just metadata now, it becomes data of our program in a way. Yeah, so that's Zig. I have an example in Golang, but I think it's smarter to leave it for the end because, you know, my PC is not really listening my instructions for my instructions. Okay, so next are the macros. This is a definition by ChatGPT, obviously, but I think it's a really nice definition. It says that are basically macros are reusable snippets of code or transformations that occur during compilation or pre-processing, and it basically the code is generated from that macros. That's the point of the definition, and I think it's really nice. And we're going to see now on the Rust example what's the idea behind macros and how the macros are used for a similar task. I forgot to mention there are a few types of macros in Rust: declarative macros and procedural macros. There are some differences, and it's not that important at this point, but it's just an information for you to know. So what happens in Rust when we use a macro? This is an example of a procedural macro, and it seemed the most obvious to me when I'm explaining what macros are doing. It's basically, you can imagine it as a function that takes an AST as an input, and then it transforms that AST. Maybe it removes some nodes, maybe it tweaks some values, it changes some types, or do whatever, and it returns an AST back to the compiler. And then compiler is using that code from that point and on. I hope this is understandable. There are also other examples of declarative macros. It's kind of a similar thing. The syntax is a bit different. I didn't show syntax for the proper macros, but it's basically this. For you, what you need to know at this point is that declarative macros are called with this pound exclamation sign, and that's it. Basically, this is the print anything macro, and you just pass it anything, and it will print anything. Okay. This is example of a procedural macro, and it's a subset of procedural macros called derived macro. If you remember a function from before, basically this function here, it's not really a function, it's a macro. So you would imagine that that macro is called serialize, and that basically takes this struct as an input, basically abstract syntax tree for this struct, and then it calls the macro, and we don't know what it does. But it creates some helper structures that we can leverage. For example, there is a serd.json library that's based on this serialize macro, and we can just like that print this struct, basically this value, value of user as a JSON. As you can see, we are provided with this toString function. We just pass it a value, and that's it. We have a JSON. So I won't go into implementation of this. I would say it's on the same level as template meta programming in C++. It's very, there are a lot of shenanigans inside, but it's nice that you can hide it from the user, and it provides very nice functionality. But it also can leverage the code that you already have written, and yeah, I hope this is interesting to you. Yeah, this is the output. Basically, I forgot to show this before, but it's an output of this println calls. And in the first case, we are printing the JSON, and in the second case, we are basically deserializing it back to the user struct and printing the user struct. And also interesting thing, you can see there's also derived debug here. Because of that, we can use this special tag with the question mark that basically prints the struct like this. C++. Okay, I don't have a full-blown example in C++, but I do have something from one of my previous projects. But there is not like built-in way or built-in way that you can, there's not like an usual way that you can leverage for reflection or any kind of similar mechanism. For this use case, and this use case that I'm talking about is mostly being able to get information from the struct. But you can use some libraries. There are custom libraries where you can pass it struct name and fields, and then you can use these helper functions to basically iterate through the fields of a struct. And in this example, I'm just printing it, but you can imagine a lot of different use cases for this. That's it. I have a short example. And if there are questions, I can take them now. Yes.
Can you go back to the last slide? I just want to wrap what's actually the macro. What's no, after that? What actually is the declarative macro in this snippet, I guess?
So basically, it starts with these macro rules.
Okay.
I'm not sure if that is like keyword or not, I'm not sure. But it's followed by the macro name, and then it goes a macro body. And as you can see, it takes this input, and it just stringifies it. And then it prints lns.
Okay, okay. Yeah, okay, thanks.
Yeah. Okay, I want to show a short example of reflection in Golang. And I try to be quick. Let's see. So this is an equivalent example in Golang. It's somewhat different in a sense that I'm going to show you. So what it does is it basically prints a JSON, and in the first example that I have prepared, I use this built-in Marshall function that basically takes a user struct, and based on these tags here, it based on them creates a JSON type, as you have seen in this output here. It's not a JSON type, it's actually a JSON string. I'm just printing it with the JQ CLI tool. But I have created a similar thing with custom function that does similar thing. Okay. Okay, let's see what this other function called struct to JSON, that's how I called it. It's custom function. Let's see what it does. So basically this function does a similar thing, but it also adds a type here, as you can see. And that's not something that you can do, it's not a built-in thing that you can do, but you can make a custom function for it. And if you look at it, it's actually kind of similar to Zig example. Basically, we reflect the struct type here. We take a struct type, and we're using buffer just because in Golang the strings are immutable, and we're using a buffer to store the string. We take number of fields from the struct. We iterate number of field times with this counter I. And then we use these helper functions to transform field to JSON. This is also a custom function. And it takes these two let's say, structures that help with reflection. And if I go into that function, you can see it basically gets the tag, JSON tag. If you look here, this is a JSON tag. But I can change it not to use tag, but to use a name instead, field name instead. And if I run the program now, you can see how these are now uppercase, and before they were lowercase. And that's because in Golang you use uppercase to make fields public. And you can use these annotations. These are just, like a metadata that you can use for different kinds of things. For example, for ORM, it's used for validation and stuff like that. And basically, we just print this type and value. And I don't know why there's two lower, but okay. And yeah, we do similar thing as in Zig. We also do type checking here, switch on type to know how to print it.
Yeah, the only Zig was compile time, right?
Yes, right.
And this is runtime, like everything.
This is runtime, and in Zig you have a very nice boundary between compile time and runtime. And even here you can see, for example, when you're getting a field, you actually use a type and you use that helper structure that's based on a type, not on a value. So even there is some awareness of that boundary here, but it's definitely runtime, and there are performance impacts. So yeah, I mean, but when this, I don't know how many of you are familiar with Golang. These tags, JSON tags, are something that's used all the time, and it's used. As you can see, for this Marshall function uses it, but also some other functions that I know, like some other libraries use it for serializing, deserializing, JSON, YAML, all other formats. That's pretty much it. If you have questions, we will.
Just a comment that I think that reflection is in for C++26.
Okay, that's great news. So. Yeah. I don't want to be optimistic, but.
Yeah.
Yeah.
Okay. A suggestion small for C++ side of things. There's currently a boost described library by Dimov, which is kind of similar to kernel functionality, but a bit more. It's supposed to be like the base for what we can do without reflection, but kind of like it. And
in C++?
Yes. You kind of do the same thing. You declare all the type name, the field types as well, and you can also declare the type via enum. And then you have infrastructure to take the types, take the field names from the type name. Yeah. And also you have boost pfair, which you can use to enumerate through field field members.
Mm-hmm.
Yes, so it's kind of useful maybe if you do databases or some primitive serialization types where you only need like an order of members. But as well, you need to have some external structure if you want member names.
Yeah, okay, so yeah, I mean, I'm familiar with that. The essence of this example, it is having field names. But yeah, in some occasions when you don't need field names, it can be very useful. And you can also have like custom functions that you can use on tuples, I guess, and whatnot. Okay, if there are no further questions, that would be it.
Something Slack. I didn't. I did direct message. Slideshows. Yeah, so let me first introduce myself. I'm Peter, and I'm going to talk about taming compile times in C++ today. So motivation, like you run your program and the whole day passes. So in our example, it takes like 300 seconds, which is too much because when you scale it to the number of people that you have in the company, you basically lose a month each year, which is insane. So, what's the solution? Modules, we have them, they're cool, but no, like they're useless. First you cannot use them, no compiler supports them, even when you use them, you get no speed up. So like, I don't know why we even added them. It's really a pity, like, so you need to profile things, and like, profiling compile times is not really a standard thing. You need compiler support, so GCC has it, Clang has it, like, I guess that Microsoft has it as well, I just don't know what it is, nor do I care. Like, so you add this magic flag, it's either ftime report or ftime trace. You get this magic JSON file which has all of the metadata for the actual compilation, and the next step is to create a flame graph from it and see which parts are hot and what actually takes the time. So a logical thing to do then is to use one of the flame graph visualizations tools that you could find online. So you have like the Chrome tracing one and the flamegraph.com one. The problem with these tools is that they're worthless. Like similar to modules. The problem is that, like, so if you're trying to speed up your compile times, you're doing it because it takes like 5 minutes, 10 minutes, an hour. And if that happens, like the actual flame graph that the compiler generates is too large for the actual online tools to parse, and you just freeze your whole computer. So you basically need to use the custom tools which you get from GitHub. There's like few things you do, and like after you do all of this, you get a pretty flame graph like this. So essentially, what do we see from this? Probably nothing, but essentially there are two big parts. In the compilation process, we have the front end and the back end. The front end is responsible for essentially two things. One is the parsing of the source files, and the other one is template instantiations, because we only write templates in C++. And looking at this graph, we could see that, like, so this part here is template instantiations. So we need to do something about that. Yeah, finding problem, template instantiations. So yeah, so if you go back, you kind of see that there's this thing that keeps on repeating. So I guess that's the problem. So let's take a look at that class. It has like 4 lines. It's so beautiful. I was so proud when I wrote it. It like added 10 minutes to our compile times. And you know, you have a problem and you want to optimize. And like, we're programmers. There's only one thing that we know to do when we need to optimize something. So you like just inline everything, you know. So you inline everything. It's like 10 times larger now, but yeah, it's gone. Like you don't have it anymore. So you get the speed of 10x. So like it's so fun. Like we spent like 30 years, 50 years of compiler development, and the whole premise of what compiler does is inlining. Like that's the only thing it does. And then you have compile time program, and they're like, yeah, we're not going to inline the syntax. Like just inline the syntax. Why do I have to do it manually? Yeah. Thank you for your time. Any questions?
Now I think that we have one online speaker directly from Czech Republic. Let me see if he's...
Yes, I'm here.
Yes, Milos is still online, but we do not hear him. Just a second.
Wait.
No. I hear you. Just give me a second, Milos.
Okay.
Can you say something, Milos?
Yes, something.
No. Just a second. This is it? Mm-hmm. Mm-hmm. Just a second, Milos. We have some audio issues.
Milošu, reci nešto.
Nešto.
To je, live si, share screen present.
Ok. Jel ima pointe da disablovanje sharing za attendees? Sad može. Jel ima pointe da uključujem kameru?
Možeš da šeruješ sad?
Da.
Ali stavi ga na TV. Just a second so that we see the slides.
Yeah. Okay, I think you can see. Why is it so tiny?
Yeah, so pretty.
Is it okay on the screen because it's small on my screen for some reason?
Yeah, we'll fix it if.
No, this is something on my side, I think. Stupid. Let's try opening in Firefox or something. No.
By the way, Miloš is calling in from Prague.
That application. Yes, that's why we are having difficulties.
He's now a famous conference speaker, so he's not attending live. An international conference speaker.
Where is present image presentation mode? So now it should be full screen, okay?
Yeah. Cool.
And somehow it got missed. Okay, doesn't matter. So I actually asked to be last because we were all talking about these very difficult topics, and it's the end of the year, it's the holidays, so like we need to take it easy. First things first, what is Hallmark Countdown to Christmas? Since 2020, Hallmark has decided to basically generate 30 Christmas movies every year and then just post them or air them or whatever, starting from October actually, like right after the Thanksgiving and going all the way almost to Christmas. And the movies are not really, well, it's 30 of them, so it's not some high quality stuff, but they are meant to make you feel good. Like you just relax and enjoy the magic. And there is this basic construction of a Christmas movie or Hallmark Christmas movie. The main character is a girl, and that's something I actually realized when preparing the slides. Like of all the 20-something that I watched this year, it's always been a female main character, and there is some tension around Christmas, like bad memories or fight with family and whatnot. Then she goes back to hometown or to some like idyllic Christmas village, whatever. Everything is great. Things are getting better. And then some time, like 15 minutes before the end, there is some twist, which is just not really a twist, but yeah, you need something. And then it's resolved and you have a happy ending and the Christmas is saved. So let's take an example of this Merry Scottish Christmas. I actually watched this one with a friend, and he was talking in the beginning. You know how some people are. So I kind of missed the part that these two are brother and sister, and you assume that they are going to be, together. So I'm like, okay, but if he's her brother, then who is she going to fall in love with? This guy shows up. Of course, they are going to fall in love. They are going to be together in the end. You know it, like from the moment you see him, you know that's what's going to happen. At one point, their mother mentions how she would like grandchildren, and this guy is actually married, And this is where they talk about also how his relationship is tense and blah, blah. And you know that the movie is going to end with the next year's Christmas, where they are all together and happy and have a baby, and that is exactly how the movie ends. And now you are wondering, what does this have to do with C++? Well, code reviews. Now, if it's not obvious, I would like to do the code reviews the same way I watch a Hallmark Christmas movie. It should be predictable. I should be able to tell what the function does and how it does it just from the name. Well, it would be nice, but in general, the code should be predictable. Like recently I had a bug where the cache wasn't cleared, but there is a function that's called clear cache that is called, and then you find out when you look at the code that actually there is a condition and blah, blah, blah. Like, I don't want those plot twists. I don't need the drama. I want, like, if I call a function that's called clear cache, it needs to clear. I don't care what it needs to do to clear the cache. If it needs to like blow a fuse and shut down the whole server room, the whole building to clear the cache, it needs to do it. Like, just get it done. I don't care. And also, when you post your code on review, you can ask yourself, is this code simple enough to be a Hallmark Christmas movie? Is it predictable enough? And of course, it's not going to be, but then ask yourself, why isn't it? And what can I do to make it more like a script for a Hallmark Christmas movie? And now he wasn't, I assume that he wasn't inspired by Hallmark movies, but in the closing keynote from Meeting C++, this year's Meeting C++ by Dr. Ivan Čukić, he came up with this idiom-driven development, or I don't know, maybe stole it. But I do love this idea, idiom-driven development, because unlike the cult of design patterns, where you have to fit your problem into an existing solution, which is how most people, I think, use it, you can have your specific idioms for your code base or your company or just your team, whatever. And anyone that's been there long enough should be able to recognize those idioms and should just be able to predict what is going to happen next based on the previous knowledge. And also, if you're wondering why I have Klaus's picture here, watch the keynote, it will be clear. And this isn't really the most important thing from this lightning talk. The most important message from Countdown to Christmas is this very, very corny cliche line, but I really love it. Word of advice, don't peek once in a while, just let the world be a magical place. You know, it's the holidays, enjoy it, take it easy. And if, you know, all this prettiness has warmed your cold programmer hearts, these are some of the charity organizations in Belgrade. You can go and, I don't know, donate, do something nice. And like, even if you don't go here, there are unfortunately more than enough people that can use help and, you know, do something nice. It will also make you feel good if doing good things for others is not enough for you. And lastly, I need to give credits to this sites Carnival site where I got the slides from, because I mean, obviously I did not create something this beautiful. Thank you, and happy holidays.
Thank you, Miloš, especially for the last slide, of course. So I think that we are at the end of the lightning talk presentations. And what I would like to say, big thanks to all of you who are here, and big thanks to all the people that prepared the talks for today. But also, I would like to thanks to all of people who spoke this year and the previous one and so on. So preparing presentations for meetups is not an easy task. You need some time, free time, spare time to prepare it, and of course that's only because you like this community or you want to be a part of this community, and thank you for that, because it's very valuable to have people presenting here. It's not the thing that it's not the idea that 1 or 2 or 3 people present. The idea of this community is that all of you can present whenever you want and whenever you have some nice ideas. Also, if you're not very sure how to prepare your presentations and what to prepare for some meetup, you can contact me or Dusan. We will have some advices for you. And if you're more comfortable to have to speak in a lightning talk format, then why not? We will collect the topics. And last but not least, I would like to thank Peter and Dusan who are here because they were a major support this year, not only from the technical perspective. From the technical perspective, of course, Dusan is doing all of the tech things recently, but also they supported us quite often, and this place where you're currently is something they helped us to get into, and big thanks for that, guys. And it's not easy to organize such things, and unfortunately we also had some technical difficulties today with the presentations, and I already spoke with Dusan. Hopefully in 2024 we will resolve some of these difficulties. These are minor difficulties. It's not so important. What is important that you're here, that you're creating contacts, that you create friendships, and of course to meet with people who share the same ideas and the same passion for C++. And my last sentence, maybe, before we go somewhere for a beer. Happy New Year. Enjoy with your families, and we'll take some lessons and hopefully see you in 2024. I think now that we will stop